Hi everyone, today I'll be teaching you how I'll be walking you through a circuit for an excitatory circuit and an inhibitory circuit. And so I have my first circuit right here. You can see it, there we go. And so first I'll take you through the presynaptic. This is the main neuron we'll be looking at, and so this is for the presynaptic neuron. And so let's zoom in a little bit. As you can see, this neuron will will release glutamate, which is an excitatory neurotransmitter. It'll bind to AMP-A receptor on the postsynaptic cell, our main neuron. And so you can see that it's released here, and you can see that the receptor is right here for glutamate to bind to. And so once it binds to, there's an influx of sodium that will happen, which will lead this cell to depolarize. And so this receptor is also ionotropic, which means it opens an ion channel. And so then glutamate has now binded to that receptor, and so sodium has started flowing in. This leads to depolarization that will move throughout the cell. And we have these voltage-gated ion channels right here. And so here, first, the sodium one will open, and sodium will move in very quickly, which leads to a rapid depolarization of the cell, which will bring us to threshold and will generate an action potential for the cell. Then after the cell has depolarized, it'll begin to repolarize as the potassium voltage-gated channels will open, and potassium will start flowing out of the cell, which will repolarize the cell, and they're also very slow to close, so it'll actually end up undershooting the resting membrane potential, and it'll become hyperpolarized for a short time, which is the refractory period. And so as we move down the cell, you can see here we have voltage-gated calcium channels. And so once the cell has been depolarized enough, these channels will open and calcium will begin to move through the cell. This influx of calcium will allow these vesicles with more glutamate, with more of the neurotransmitter glutamate inside of them, to bind to this axon membrane, and which will then allow the glutamate to be secreted and will affect this postsynaptic cell. And so you can see here, that's the vesicle bound to the membrane, and these are some glutamate neurotransmitters that have been released. And you can see this is the same AMP-A receptor from the previous cell that is going to be bound to glutamate here, and a similar circuit will take place, which means that this neuron will also be excited and will reach action potential. And so that is my first circuit, an excitatory one, which we'll just run through again very quickly. Releases glutamate, the glutamate binds to this cell, generates an action potential, and this cell will once again release glutamate, which will generate another action potential in the final neuron, which means this is an excitatory circuit. Now we have the excitation of an inhibitory circuit. And so we'll zoom in again. Here are my cells, and so the first two steps are very similar again. We have our presynaptic cell, which will release glutamate. It'll bind to the AMP-A receptor on the second neuron. This will lead to an influx of sodium, leads to depolarization, leads to an action potential, and then we'll follow again. It goes through the voltage-gated ion channel. Sodium rushes in, potassium will start to rush out, which will send this cell back to its resting membrane potential. But when calcium rushes in this time through the voltage-gated calcium channels and the vesicle binds, it's not glutamate that this second cell releases, it's actually GABA. And now GABA is an inhibitory neurotransmitter. And so GABA's receptor is the GABA-A receptor. So once GABA binds to this postsynaptic cell's receptor, the GABA-A receptor, it actually causes the negatively charged chlorine to move into the cell. This leads to a hyperpolarization here on this postsynaptic cell, which means that the cell becomes so polarized that it is not able to generate an action potential, and no neurotransmitter will be released from this cell. So let's just run through that again really quickly. Glutamate is released here, This excites this neuron to release its neurotransmitter. However, it releases GABA, and when GABA binds to GABA A receptor on this postsynaptic neuron, it causes chlorine to move into the postsynaptic neuron, which means that GABA is an inhibitory neurotransmitter. This cell cannot get brought to an action potential, and that is why this is an inhibitory circuit. Thank you.